Okay, this video is a brief introduction to Circuit Wizard, an overview of what you might need to know to get you started with your pet feeder project. So the first two exercises, traffic light project and the dice project. We're going to cover the operations needed for the most basic of traffic lights to start with. Part two of this video will give you a few more tools useful for doing slightly more advanced functions. Okay, so we'll go File New. Just so you know, Circuit Wizard it's a really good program for lots of different applications. First of all, we use it to program Genie pick chips, but you can also simulate other types of circuits before building them in real life. So if they work, you can measure voltages, currents, etc. You can watch them components explode if they're overloaded, for example, without having to make a nasty smell. Anyway, right, so just so you know, we often use two types of file here, circuit design and product design. Just so you know, the product design is a slightly more kind of basic, kind of secondary school friendly program file. Whereas circuit design does actually use schematic circuit diagrams, and you've got a lot more components to choose from in that. For the traffic light exercise, we'll just start with the basic product design. So we'll go with A3 design. That's obviously the page size, so you can fit more on. It's just more space to work on. And then flowchart. It's just a visual programming method rather than using BASIC, which is a linear set of code. It's a very old programming language, BASIC, but it works in a line of code. So we'll start with that. And like I say, you don't have schematic diagrams here, you've got pretty pictures. So we use Genie 18 project boards. If you scroll down, you'll find a couple of these here. They are actually pretty much exactly the same. It's just the way they're drawn, whether or not the components have got plugs or not. It makes no difference whatsoever. So we'll go for that one there, drag it onto the page. Now for it to work, we've still got to tell it to plug into a battery. So we're going to use a 3AA battery with clip, as you would do in the real thing. Now you notice here we've got 0 volts and plus volts here. So this is where it takes the power from. So 0 volts will go to that one, plus volts will go to that one. Now it's a bit more visual than the schematic. These wires they're okay here because they're black and red, different colours, but they can be quite annoying because you don't actually see exactly where they go sometimes. Anyway, this Genie is now ready to have its inputs and outputs plugged into. So for a traffic light, we're going to just have a momentary switch. The difference between latching and momentary? Well, latching's a bit like a room light switch, so you can press it on, it stays on. Whereas a momentary switch, like a Pelican crossing button, you push it to make an input. Push to make, it's called. You can also have push to break. So that means the input is on until you press it, and then you break the circuit. But in the case of this, we're going to have push to make. Colours are relevant, obviously. So we're going to just plug this into our digital output. You notice here we've got A or D, analog or digital. So in this first exercise, we're just going to have a digital on-off. Now you could plug the colours, they're both blue. So one goes to plus volts and one goes to the digital input. So it means it's taking a 5 volt high, and when you make this circuit, it goes through a protection resistor into the input. Okay. For the outputs, I'm going to do a really straightforward traffic light. So I'm not going to do the full requirement. Again, colours are actually useful here, so we can see what we're doing. So obviously we want a red, an amber, and a green. These are the motorist lights rather than the Pelican crossing red and green man. I'll let you do the slightly more advanced one with red and green man. Hopefully you'll have enough knowledge to carry on with that. So green will put on input output 0. Now it's important now to notice this is quite cryptic because it isn't apparent when you use these ones. It is on here. You notice you've got a long stalk and a short stalk. LEDs being diodes only work in one direction, so it's important to wire them up the right way around. If you move it, you can see you've got a kind of flat side on that side. Now, those that you remember, the short stalk and the flat side are the barrier, so they don't let current flow from positive to negative through that direction. So in other words, positive wants to be this side and it goes through to the negative. So yeah, just so you know, short one goes negative, long one goes positive, or in this case, the barrier, the flat side, is goes to negative. Now also you might notice that the common rail, can you see this line here is all connected together, is 5 volts, or rather 4.5 in this case. So the positive will all go to this common rail. Now quite often in electronics things go down to 0 volts. When they come out of the chip, the gate opens and the electricity goes down to 0 volts. It's actually the other way around. So when the gate opens, all of this high voltage goes into the chip and then out through a drain or whatever. Don't need to worry about it. Now just so you know, this is the Genie chip. This is the programmable microcontroller. And then this ULN2803 is a bank of transistors. Further along the line, those that get a bit more advanced, maybe with their NEAs, might want to have quite a nice little compact chip, and they'll just use this Genie 18 on its own. Now, if you want to use LEDs, you're going to have to amplify the tiny little output and put your own individual transistors on the outputs where necessary. You might want to have bigger transistors than this bank of transistors. Say if you're using a motor or something like that, you'll want to have a bigger transistor than this. So it's good to customize your chip, your circuit. What you might be proposing in real life will be obviously a cheaper product if it only uses the circuitry it needs. It's going to be smaller. There's lots of benefits to obviously just customizing your own circuit. Anyway, these checked, yeah, these all go from positive and then the negative connects to the output. So Q2 there, Q1 there, and Q0 there. And like I said, it's not very intuitive sometimes if you're fault finding or looking at someone else's circuit with this kind of secondary school key stage 3 product design mode. It's not very professional like that. It looks a bit pretty, but it's not very useful in that respect. Anyway, we've built the hardware, virtual hardware here. Now we can program it. So down here on this tab, you've got flowchart. So this will be tailored to whatever we've dragged onto this here. So if we use the Genie 8 with fewer inputs and outputs, when we look at outputs, for example, we're going to have the corresponding number to which the chip is. So in this case, we've got all 8 outputs here. With inputs, we use this diamond, which is a question. So it's asking, is input 1 pressed? You'll notice we haven't got 8. In fact, we haven't even got 6 here because I think 5 is reserved for the reset pin. It's not even apparent there, but just so you know, we tend to just use 0, 1 and 2. So here we've got the most basic functions. Question, is an input used? Answer, yep, let's send some outputs. Okay, and when you double click on them, you've got the options. So we can choose either to have outputs off. So all of these outputs are going to be off. But we're going to have output 1 on like that, for example. So it will just say which one is switched on. High on Q0, which means we'll get a green light. Now it's important to say when things are off as well, because had the last command been illuminating this red light, and we don't tell it to turn it off, it will stay on. So in other words, I'll show you in a minute. Has the Pelican Crossing button been pressed? So this is D0. So we're going to ask, is D0 on? Like that. Okay. You can also put a caption here. We'll just state is button pressed. And it'll be there. So when you're building a long, complicated flowchart, it's quite useful to just annotate it for yourself as well as other people looking at what you're doing. This one we can call it green light on, I think. Let's check that. Yeah, I'm pretty sure green is Q0. Yep. Now I can Control C when it's highlighted, Control V, and I can change this to amber. And then we'll just have that one on and that one off. Where it says T in yellow, it means it'll swap whatever state it was. So if it was illuminated, it will switch it off. If it wasn't illuminated, it will switch it on. In this case, we just definitely want to have it off, so we'll just leave it like that. And then red light on here. Oh, not that one, that one. Okay, so I've got my sequence written out, which would be what would happen if you press the Pelican crossing button. Now, the trouble is, and I can demonstrate this, if I draw a circuit, so is the button pressed? As soon as I draw something out of this question, it assumes that to be the yes answer. So if the button's pressed, this happens. If it isn't pressed, what happens? Well, we carry on asking until someone presses the button. So I find actually if you draw, no, that works. So yeah, now this isn't going to be a valid flowchart because it needs to know what happens after that. Well, after the red light happens, it stays on, and then the amber light comes on, and then the green light button. Anyway, we'll just try that in a bit. Let's see what happens if we go around and finish that cycle. If you go back to here and press play button up here, you'll see what happens. So no lights are on here because we're in this state and we haven't told it to turn any lights on. So really we want that green light on up here. Now if you notice the arrows aren't in its place like that, then it hasn't been connected. So you might have to delete your flow arrows and redraw them like that. Oop. So let's try that again. So now we should just have a green light on. Yeah, and then we press the button. What's happened there? It's happening instantly. So we need to tell it how long these lights are on for. Now, there's two ways of doing that. You can either scroll down and use a wait command, which is a time in seconds where the program just stops, nothing happens. Now further down the line you might notice that can be a problem because you might want to be simultaneously checking stuff whilst things are paused. Or you can use a pause command, which is in milliseconds. So if you want a very quick flash or something like that, we use this one here, but wait's okay. Otherwise, if you eagle-eyed of you might have noticed here, add wait command after settings. So if we click that and say 1 second, and this one the same, and this one. Now you might want to be slightly more realistic for the periods in which it works. Obviously the red light, that's not much time to cross the road, 1 second, but when you're testing circuits, it's a good idea just to keep those times minimal, just so that you're not sitting around watching your program. You've just got enough time to observe it's working correctly, and then you can put 20 seconds or whatever later on. So now if we do it, green light, press it, amber, red, and then back to green. Obviously that's not the correct sequence. You might want a flashing amber. You might notice some Pelican crossings are flashing amber lights. Some of them are red and amber as they get ready to go green. Choice is yours, but we haven't got the green man and the red man. Now the higher scoring marks might want to think about the fact that the traffic light wants to stay green on the traffic to let the traffic flow for maybe a minute before it goes amber and red again. If there's lots of pedestrians, you're going to have to let the pedestrians wait a little bit. You'll find different places, depending on the road and the amount of footfall on pedestrians, they're going to have different sequences depending on what it is. So there's no definitively right, correct way of doing it. However, you might want to ask the question, has the green light been on for a while? Now, we'll cover that in part 2 with slightly more advanced things. But you should have enough tools here now to do the very most basic traffic lights thing here. Like I said, there are some ways of doing slightly more advanced circuits. There's some ways of tidying up long. So if you're going to have the amber light flashing 10 times, in the next video I'll show you how to compress and tidy up long lines of code. So that's it, part 1, and join me for part 2.